Good morning. So, in today's class, we are going to discuss an important topic of climatology, that is winds, right? Precipitation, that you normally call rainfall. Okay, though it is not always rainfall, it can be in the form of snow, means can be snowfall, or it also can be in the form of sleet, right? Hailstorm, that you know by this name, right? So, but all of them, or technically they are called precipitation, means the water that precipitates in the climate, right? And one of the most important topic in uh, climatology, that is jet streams. They are actually important to know about the upper air atmosphere, or you can say that how upper air atmosphere is that is related with the lower air atmosphere. For example, monsoons. You know that Indian climate is largely monsoonal climate, right? And if you want to explain the monsoon, there are many theories like thermal concept of monsoon. But this concept has its limited applicability, right? Because in the conditions of Indian subcontinent, monsoon's behavior always changes, and that is because of the changes, or you can say the factors which are caused by this jet streams, right? And there are some also factors related to monsoon, like Indian Ocean dipole, like El Nino southern oscillation. We will discuss all of them. Then we'll discuss this monsoonal concept of in Indian monsoon, right? In Indian climate chapter, right? So there we will see the application of this jet streams in the context of Indian monsoon, right? So today we'll discuss winds. In our last class, we have discussed the different belts, pressure belts in the Earth's system, right? Like this is the polar high, then this is low, then again this is high, then again this is low, then high, then again low, this is high. This is the normal pattern of pressures. Mean in this belt there are high pressure cells. This is not a whole continuous belt. Uh, Particularly, there are many high pressure cells in this belt. Likewise, in this equatorial zone, around 10° north to 10° south, this is the zone of low pressure, right? This is the belt of low pressure. And you know that because of this pressure differential, this pressure gradient, this is called the pressure gradient force. Means if here is a high pressure and here is a low pressure, okay, then there will be a tendency of wind flow from high to low, right? So you can see here that from this high to this low, there should flow a wind like this. There should flow a wind like this, right? But they are not exactly in this direction. Actually, they are like this. Means they are deflected to their rightward. And I have discussed this, that this is because of the Coriolis force, right? So one force is pressure gradient force, another force is Coriolis force. There is also a third force that you can call the frictional force, right? Friction. That is because these wind flows, like here, these are the winds of trades. Okay, these are known as trade winds. Here, westerlies. Here, polar easterlies. I have discussed all of them in the last class. That these are the planetary winds. Planetary winds, or you can say that they are permanent winds. So these planetary winds or permanent winds, they are surface level winds. They are surface level winds, right? So these planetary winds or surface winds, they are horizontal to the surface. If this is the Earth's surface, a wind is flowing in this manner, right? Like this is a trade wind. It will also be affected by a frictional force. Friction. And you know that friction is in the opposite direction of the movement of the wind. Means if a movement is in this direction, wind is flowing in this direction, friction would be in this direction, in the opposite direction, right? So a wind is affected by these three forces. One is pressure gradient force, the differential between the high pressure and low pressure. Second one is the Coriolis force. Coriolis force is caused due to the Earth's rotation. Means if Earth wouldn't be a rotating planet, there would be no Coriolis force, right? Coriolis force is caused because of the Earth's rotation. You know it. And it is explained by this formula. Yeah. 2v sine theta. Here v is the velocity of the wind and theta is the your latitude angle. Like in equator, theta, you know that theta is 0 degree. In polar area, theta is 90 degree. 90 degree. That means exactly in equator, you know that sine 0 is 0. The value of sine 0 is 0. Means where theta is 0 degree, that means on the equator, sine 0 will be 0 and this whole will be a 0. Means on the equator, there would be no Coriolis force exactly on the equator, 0 degree. And as you go in higher latitudes from equator, as you go in higher latitudes, means towards the North Pole or South Pole, the value of Coriolis force will increase as theta will increase. Yeah, as we go in higher latitudes, means on poles, the Coriolis force will be the maximum. Yeah, as you go further away from the equator, because of the increase of this theta, Coriolis force will increase, and that will be maximum on the polar areas, right? One thing is also there, velocity. Means if the velocity of the wind is more, it will be causing more Coriolis force. Here, there are two factors, velocity and theta. Means it also depends on the velocity of the wind, and velocity of the wind depends on this pressure gradient force. If there is more differential of high and low, there will be more of velocity. Pressure gradient force, just the difference between the high and low, high pressure and low pressure. If both the areas, means this is area A, this is area B, difference of pressure just, okay. Gradient means slope, means if slope is more, if slope is not the means actual slope, this is the virtual slope of high pressure and low pressure, right? So if there is more difference of high and low, there will be greater speed, greater velocity, and that will be causing more Coriolis force, right? So I was trying to say that a wind is dependent on these three forces. These three forces or factors, whatever you can say. One is pressure gradient force. That is the, you can say that is the fundamental cause. Pressure gradient force. Then it will be affected by Coriolis force. Then it also will be affected by the frictional force. Right? So the direction of the wind, actual direction of the wind will be decided by these three factors, right? So again, if this is your 0 degree equator and this is 30 degree north, means you are in the tropical zone, the flow of the trade wind, you know, is this, right? The pressure gradient force, you know, it is in this direction. It should be go like this, but it is deflected. It is deflected because of this force, which is being applied. This is the pressure gradient force. This is Coriolis force. Okay, because of the balance of this force and this force, it is going in this direction. Means this direction is the result of these two forces in different directions. Okay, and there would be an apparent force of friction on its opposite direction. So this is your trade wind, right? Make this diagram. So any wind is the result, any wind which is flowing on the surface. If any wind is flowing in the upper air atmosphere, there will be no friction in the upper air. In the upper air, you know, because there would be no friction of land, right? Here, land is applying this friction, right?
Jet streams won't apply friction. Then jet streams won't be applying friction.
Yeah?
Jet streams, for jet streams, friction.
Yeah, on jet streams, there is no frictional force. There is only two forces: pressure gradient force and Coriolis force on jet streams. They are not, there are no.
Near tropopause, like you are doing near tropopause, there will be no friction.
Yeah, near tropopause means as you go up in the air, the frictional force caused by the land, it will go diminish and diminish. It will become zero after a particular height, right? Means that drag force will be there up to a particular height, but after that there will be no frictional force. The direction of the wind will be decided only by these two forces, right? So there can be a very beautiful question on this, like this Coriolis force. Based on this formula, that as velocity of the wind increases, Coriolis force will increase. As will go from 0 degree to 90 degree, Coriolis force will increase. Okay. And as we go up in the air, frictional force will decrease and it will become zero even after a particular height, right? There will be pressure gradient force based upon the difference of this high and low pressure. And this is the fundamental force because of which the wind is arising. Though it is also being decided by, means its direction is also being decided by this force and this force.
Like rising and coming down is because of pressure gradient force.
Means the origin of a wind is just because of this. If there would be no Coriolis force or no frictional force, even then a wind can flow. But in that situation, it will be directly from high to low. If this is high, this is low, wind will flow in this direction. Okay. Means if in a non-rotating planet, winds would be flowing just PGF, and if there this is a surface level wind, there will be also a frictional force on the opposite direction. These two forces. On a non-rotating planet, there will be no Coriolis force. Okay. In the upper air, there will be Coriolis force. Actually, Coriolis force has its application even in the upper air atmosphere, because all the winds are associated, they are integrated with each other. Okay, means from lower air to upper air, all the winds, they are connected with the Earth's rotation. Means if Earth is rotating, they are also rotating. So there will be an apparent Coriolis force always, even in the upper air. Yes, centripetal force is always there. Centripetal force is always there. Otherwise, there would be winds wouldn't be in this manner. They will go outwards.
I actually have somewhere actually that the main reason behind it is the centrifugal force.
Centripetal force is nothing but like Earth is rotating. Okay, there is a centrifugal force outwards. There is a centripetal force inwards. Because of that centripetal force, that wind is being attached with the Earth's surface. Otherwise, it will go outwards. Means if this is the wind with the earth, it will go out of the earth. If there would be no centripetal force, means centripetal force and centrifugal force, they are also balancing each other in a way, right? That is a factor, but not so much important. Means this is there, okay? Means this is always there with all the winds, so it is not a factor because it is being applied in all the planet, right? So again, come to the topic of wind. Means up to now we have studied that how a wind originates and how its direction is being decided, right? Now, if we divide the winds, they can be of three types. Basically, planetary winds or permanent winds. Second one is your periodic winds, right? Like monsoon, like land and sea breezes, like mountain and valley breezes. They are also called katabatic. Yeah, and anabatic. Yeah. These mountain and valley breezes, also known as katabatic and anabatic winds, right? And third one are local winds. They are permanent winds, like your trade winds, like your westerlies, polar easterlies, right? And you have studied about them, that how are they originated because of the, again and again you should practice this diagram. These are trade winds, these are westerlies, and again they are polar easterlies, right? There should be no confusion in their direction. Their direction will be like this because they are trade winds. They will come from, they are also known as tropical easterlies. So they are easterlies, so they will come from east. A wind is named after its direction, where from it is coming. Okay, because it is coming, because it is called easterlies, it will come from east. Means the direction will be like this, and this direction is mainly caused by this Coriolis force. Okay, this deflection. Otherwise, they would go like this. They would go like this. Okay, but no, they are flowing like this because of this Coriolis force. Because of this Coriolis force, they are called westerlies. Otherwise, they would go like this, but no, they are flowing like this. And they are surface winds, means visualize them like this. They are surface winds, means they are horizontal winds. Means if it is shown like this, it is not that they are going upwards. Understood? They are flowing in the surface, like this is the surface. This is the surface, they are flowing in this manner. Okay, means take it like this. This diagram take you like this. Means they are coming towards the equator, they are going towards the pole, right? Adjacent to the surface of the earth. They are all surface winds, just like these trade winds in the same direction, these polar easterlies, right? So they are permanent planetary winds and they flow in the whole of the planet, right? These periodic winds change their direction, or you can say they reverse their direction. Okay, either day and night or seasonal change in the case of, as in the case of monsoon. Like monsoon, I have discussed that there is a southwest monsoon in summer, and this is the northeast monsoon in the winter. So it changes its direction as season changes, right? In the same way, land and sea breeze, like this is a land, and there is a sea, water, right? This is a land, and you know that this is a water. Means like you are sitting here on the beach. This is the beach area, right? You are sitting here, and this is the daytime. Means sun is there. You can draw like this. What will happen? You know that because of this land and sea contrast of temperature, yeah, there will be thermal difference. Okay, means land will be heated more than this water. So what will happen here? Air currents will rise because land is more warm. It is warm, though it is cold because it is water. So because of this warmth, air currents will rise like this. Means air will be warm and it will become warmer and lighter and it will rise. So here will be a low pressure. On the opposite of that, because here this surface is colder, there will be no such air currents rising, and in comparison to this will be a high pressure here. So what will happen now? Yeah, now there will be a movement of air like this, like this. Okay, so this air, or sorry, this wind, we call air to this type of vertical. Yeah, if there is any vertical movement, it is called, generally it is called air or air current, also called air current, or also it is called updraft. Okay, if such type of air current goes downwards like this, it is called downdraft. Such updrafts and downdrafts, they occur in the thunderstorms. When we'll study the thunderstorms or tornadoes, such type of updrafts and downdrafts occur in that system, right? So there will be a wind flowing in this manner from sea towards the land. So it will be called a sea breeze.
Morning of in Arunachal Pradesh, there will be like today and tomorrow there will be snowfall will be, and some thunderstorms will come. Like now, what is the difference? Like Westerlies तो हो गया अभी, जो उसका जो impact हो गया, like आगे का चले, अभी तो चले गए, अब तो दूसरा मौसम आ रहा है. तो अभी like इस समय पे अरुणाचल प्रदेश में क्यों like snowfall हो रहा है?
Actually, there are some local regions. There could be some meteorological local regions, means some type of air current. Okay, this whole northeastern area, it acts like a valley. Means here winds come and they are, in a way, they are obstructed by the all the mountains around them. Yeah, they are trapped like. Okay, and in this trap, what happens? When air is trapped from all the sides, if for any reason it goes upwards, means there is an updraft of air, and speedy updraft of air, that will act like a thunderstorm. In thunderstorm, nothing but an updraft of air, and air also comes down. There are the snowfall is just the because of the condensation. If there is a speedy updraft of air, there will be a speedy condensation, and if that condensation occurs in that altitude, in that height, means there is temperature is below 0 degree, that will be in the form of hail, right? Means that has nothing to do with anything but only the altitude. If altitude is that much high, that will cause the all the precipitation to get converted into snow and sleet, right? So that is why hailstorms. So during daytime, you will feel such type of sea breeze coming because it is coming from the sea. So a wind is named after its source region, right? So because its source is sea, it is called sea breeze, right? During night time, the conditions will be different. What will occur? Yeah, during night time, now there is moon. Yeah, you can show it like this, that this is night. What will happen now? In the night, you know that land will be not that much. Means now the terrestrial radiation is happening. Okay. Now what will happen? Previously the land was more warm. Now it will be more cold. Okay, because you know that land becomes cold or warm easily, speedily. So it will be colder now than the sea water. So water will be warm. Means this warm and cold is only relative to each other. Means this is warmer than this land, adjacent land. So what will we see? What will be the situation now that because of this warm, air current will rise? Okay, because the air will be warmer and lighter, and it will rise. In this condition, a low will be created here. Just opposite of that, here will be a high pressure. So now the air current will flow. Sorry, this wind will flow from this high to low, and this will be called land breeze. Understood? So in the night time, sea breeze comes. Oh, sorry. In the daytime, there will be sea breeze, and in the night time, there will be land breeze. And if you are here, sitting on the beach area, means you go on the beach side, either in daytime, you will feel the sea breeze. Why is it called breeze? Breeze belongs to a cold wind. Means during daytime or night time, the wind is always cold, because during daytime it was coming from a colder region, that was sea, so it was cold. That is why on the beach side you feel very, yeah, नहीं, if you are here, आप यहाँ पे जाके बैठोगे तो आपको हमेशा ठंडी हवा आएगी, है ना? दिन के टाइम ठंडी हवा कहां से आ रही होगी? फ्रॉम द सी शोर, फ्रॉम द सी साइड. रात के टाइम बैठोगे तो ठंडी हवा कहां से आ रही होगी? फ्रॉम द लैंड साइड. Okay, because now the land is colder, so a wind will flow from land towards the sea. Okay, and you are sitting here, so you will always feel the cold wind. कभी भी बैठो जाके हमेशा ठंडी हवा आएगी, इसीलिए हमेशा ठंडी हवा आती है. ओके, जबकि रात में ये सी तो गर्म है, लेकिन रात में ऐसे हवा नहीं आ रही है ना, हवा ऐसे आ रही है, तो कोल्ड रीजन से आ रही है. दैट इज व्हाई इट इज ऑलवेज कॉल्ड ब्रीज. दिन हो, रात हो, लैंड से आए, सी से आए, इट इज ऑलवेज अ ब्रीज, अ कोल्ड विंड, राइट? Understood? Then these katabatic and anabatic winds, what are they? So they are land and sea breezes. Now, katabatic wind, or it is also called mountain wind. Such type of winds are caused by, try to note these things, okay, very important for your prelims. Yeah, caused by radiation, terrestrial radiation, right? So what happens? This is a mountain, this is a mountainous zone, and this is a valley. Okay, the same things. This is a daytime, sun is there. What happens in the daytime and nighttime? In the daytime, this area will be heated more because this is a valley, and here you know that there are many trees on this zone. Means valley is in a sheltered position. It is somewhat sheltered because of these trees and all that, and it is much below than these higher mountains. Okay, so here the solar radiation will be affecting this valley less than that this mountainous area. So it will be warm and it will be cold, right? Because of this warm, again here the air current will rise in this manner, and here will be a low pressure zone, right? Here will be a high pressure. So air current will move from high to low, like this. So such type of upslope wind, or it is called the valley breeze, right? So this pressure differential is being caused by this radiation. Here there is more radiation, right? In the daytime, here less radiation in the daytime, and that is why this pressure differential and such type of upslope wind are called valley breeze. It will be cold because it is coming from a colder region. Okay, valley is colder region in the daytime. In the daytime, there will be much more heat here, and this valley will be protected in a sheltered position, right? What happens in, so this is the valley breeze. What happens in the night time? Same mountain, same valley. Here some trees. Okay, it is a sheltered in the same way. Now this is a moon, night time. Now in the night time there will be terrestrial radiation. Okay, what will happen? This land will be colder because of more terrestrial radiation. More terrestrial radiation because it is in a sheltered position. Terrestrial radiation will be there, but not so much high as here. Okay, like in the daytime, it was much more heated. In the night time, it will be much more cold. Okay, because of that cold, here will be the high pressure. Here, because of that warmth, air currents will rise, making the low pressure over here. Right? So now the air currents will descend in this manner towards the valley, and these downslope winds are called mountain breezes, or they are also known as katabatic winds. Right? So they were anabatic. They were. These valley breezes were anabatic winds. Okay. These mountain breezes are known as katabatic. So you will have to practice such type of diagrams, right? Means
So mainstream we do like this master data.
yeah, means these means all this study is not applicable to your prelims. They will be equally applicable to your mains. Okay, there you will have to draw these diagrams, you'll have to detail them, you'll have to attach some examples with them. Okay, like such type of katabatic winds, where are they? Means you can even name out regions from India, like in the Dehradun and Masuri. Like this is your Masuri. This is Masuri Hill. Okay, and this valley is Dehradun. Actually, I have felt this. One of my aunt lives there. Okay, मौसी बोलते हैं ना, मौसी है ना, तो मदर के सिस्टर को, तो या तो मेरी मौसी उधर रहती हैं देहरादून में, तो उनकी छत पे जैसे मैं जाता हूं तो उनकी छत से ये मसूरी ऐसे दिखता है, जस्ट लाइक दिस. ओके, एंड आई हैव फेल्ट दैट ड्यूरिंग नाइट winds are coming down the mountain, down the मसूरी साइड. मींस जैसे रात में उनके छत पे खड़े हो जाओ तो आपको फील होगा कि वहां से बड़ी तेज स्पीड से हवाएं मसूरी साइड से आ रहे हैं. ओके, इन द सेम वे ड्यूरिंग डे टाइम अगर आप मसूरी जाओ तो आप अगर पहाड़ की तरफ खड़े हो तो यू विल फील दैट विंड्स आर कमिंग अप स्लोप. आपको फील होगा कि देहरादून के साइड से हवाएं ऊपर को आ रही हैं. यू विल फील दैट. So you can give such type of real life examples from India.
तो सुबह वैली में बैठ कर कर सकता हूं.
जो सुबह
अगर जो आपको दिन में बात करें तो
means here all the means this is colder region, valley है, दिन के टाइम पे वैसे ही कोल्ड रहेगा. अगर आप माउंटेन में यहां पे अगर बैठे हो इस साइड में जिधर से हवा आ रही है, not on the other side, you will feel that cold air, right? Means you will be relieved somewhat, right? So then again the third type of periodic winds are monsoon, that we will study under the Indian geography topic, right? So now come to local winds. Local winds are caused by some local factors. Okay, the factors could be like
the only radiation is the reason for this outdoor mountain and valley research.
yeah, means those breezes are caused by largely by radiation differential, right? Though also a thing can happen that winds would be coming from this side, they would be rising in this manner. Okay, and means if you are here, you can also think that this is the upslope, this is the downslope wind. So can this upslope wind be called a valley bridge and this downslope a mountain bridge? No, this is not a valley breeze, this is not a mountain breeze, because that breeze particular word is attached with that katabatic or anabatic word is attached with the radiation factor, right? So these winds which are caused by this push of air, means if a wind was flowing in this manner, it encountered a mountain, okay, it will rise. So such type of upslope wind is normally called just, it is called windward, okay, and it is called leeward. This is leeward wind, this is windward wind. Just they are known as this. Okay. Or it is also called rain shadow wind. Now coming to the topic of phone or chinook. They are such type of winds. Yeah, this is a local wind. This is a local wind. Chinook is like this type of wind, downslope or leeward wind. Chinook.
Local winds are these winds.
Local winds are these winds. Means local winds are known by their local names. They are not the general names.
Like this mountain is your example. So इसको भी local wind हो सकते हैं, जो upward and down slope wind.
Yeah. Means like this wind, Fawn or Chinook. This is a leeward or rain shadow wind, right? Like this is a like this is a rock. This is your Rockies. This is your Rocky Mountain, right? And this is its eastern side. You can say that this is the eastern slope of Rockies. From here on is the vast slope of Great Plains. From the foothill zones of Rockies, there starts a plain. The plain made by Mississippi, Missouri, and all those rivers. Okay. So what happens that on the higher latitude regions, means the area which is more common to Canada and USA, means those areas which are higher in latitudes. What happens there? There is always grasses in these plain areas. Okay, they are important for animal grazing. But what happens that during the winter, this grassland is snow covered. During the winter, this grassland is snow covered. What happens whenever such type of downslope wind comes? It is a warm wind. And as it comes, it melts out this snow covered zone, and those grasses are now ready to be grazed by animals, by cattle there. Okay, means they are beneficial, such type of winds, that Chinook in the eastern slopes of Rocky Mountain, that is beneficial for the cattle ranchers of Great Plains. That is why, because it melts down the snow here, that is why it is also known as the snow eater. The Chinook are known as the snow eater. Locally, they are also known as snow eaters because they melt the snow there, and now the plains are ready for the cattle. Okay, means all the grasses are now open. The same type of wind flows in the northern slopes of Alps in the Rhone Valley of France. This is also the same type of downslope or rain shadow wind, right?
But these two are only downslope winds.
Yeah, they are downslope. Means on this, that is why I am writing here on the eastern slopes of Rockies, because on the eastern side they are going downslope, right? On the northern slopes of Alps, here, like this is your Alps mountain, right? So it is, this side is southern side, this side is northern side. So they would be going down slope on the northern flank of the mountain, right? Alps is, they are extended like this. Rockies are like this. Rockies are extended in such north-south manner. Okay, Rockies are like this only, and Chinook is this wind coming down on the eastern side of the Rockies. Now, what will do it? it will snow, it will melt the snow here coming down because it is a warm wind. Why it is a warm wind?
As you told, particles जब पिछले क्लास तो particles दूर होते हैं उसका एनर्जी का वार्म कम होता है
हाँ
जो ऊपर चल रहा है और फिर नीचे आता है.
Yeah, now during the coming down they will be more and more compressed. Yeah, that is known as adiabatic heating. Adiabatic heating. So this warmth is caused by adiabatic heating. So
both are because of adiabatic heating.
yeah, both are. They on the eastern side of Rockies, they are your Rockies, and they on the northern side of northern flank of the Alps. No, it is not Rhone Valley. Though it is, because Rhone Valley is associated more with the Mistral. There is one more local wind in the Alps region that is known as Mistral. So Mistral flows in Rhone Valley. Mistral. This is the factor. This is coming downwards. Okay. A wind was flowing in this manner on the other side of the mountain. Like this was Pacific. This was Pacific Ocean. Na? If this is Rockies, this is the Pacific Ocean. The wind is coming from this side, riding the back of the mountain, then coming downwards. While coming downwards means on this side, it will be causing rain. There will be rain, and this is the rain shadow area. That is why it is also known as rain shadow wind. Here on this side of the mountain, there will be rain, because here what will happen? They will pick the moisture over here. Okay. Then while going upwards, there will be adiabatic cooling. That adiabatic cooling will cause condensation and rainfall will occur there. Okay. While coming downwards on the other side of the mountain, it will be getting more and more heated through adiabatic process. And you know that if there is heating, there can be no condition of condensation. That is why there is no rainfall on the other side. Understood?
Can we name like अगर लिखना है तो factors अलग से कुछ बोलेगा. अगर किसी को बोलना है कैसे बोल सकते हैं तो कॉन्सेप्ट पूरा बताना है.
मतलब
अगर कोई पूछे तो local winds में what are the factors?
Local factors. Local factor, local differential heating and cooling, local differential, you can say causation of pressure differential, local factors of pressure differences, or like some of the winds are caused by this, they are caused by this up slope or down slope movement of the air, right? Mistral happens to be on the Rhone Valley of France. Okay, it is a chilly cold wind. Mistral is a cold wind, though both are these winds are warm winds ना, तभी तो स्नो हीटर है ना. They both are warm wind, but this is a cold wind. Yes, see it here. Yeah, here you can see the deflection due to the Coriolis force. Here in the equator, because Coriolis force is 0, there is no deflection. Okay, here in this zone, if the wind is flowing in this direction, ITCZ, intertropical convergence zone. Just simple. Okay. Intertropical convergence zone means here there is a zone, yeah, around 10 degree north to 10 degree south of the equator. This zone is known as ITCZ. Okay. Intertropical convergence. Somebody is asking. Okay, air gets heat up due to compression. Yes. So it is. No, she's saying that air gets heated due to compression means that downslope air. Downslope air. Yes, Pooja. So intertropical convergence zone means just that here in this zone, these trade winds from this side and this side, they are converging with each other. Nothing more than that. This is the intertropical, means between the tropical zone. This zone is between the tropics. These are tropical zone, this and this. So this zone happens to be between the tropics, and this is the convergence zone of trade winds. As sun's location goes towards the Tropic of Cancer and Tropic of Capricorn, this ITCZ also shifts. There occurs a shifting towards the north or towards the south of this. This ITCZ will also shift as the sun's location shifts towards the Tropic of Cancer and Tropic of Capricorn. You know that Earth is in a tilted position, right? And sun's straight rays, when they, yeah, you can see it like this, that first sun's rays will be falling on 0 degree equator straight. Okay, as northern summer comes, means sun's then its farthest location will be on the Tropic of, this is your 0 degree equator, this is your Tropic of Cancer, and this is your Tropic of Capricorn. So on 0 degree equator, Earth sun will be farthest location towards the south, towards the north will be on Tropic of Cancer. Then again it will fall on 0 degree. Then again sun will be on the Tropic of Capricorn. Again it would be here. Again means this will be in this manner. Means in a particular year, sun's location will be from here to here to here to here, then again here. Okay. So as sun will be going from here to here, this ITCZ will also shift ना. ये भी जाएगा 10 से 15 डिग्री ऊपर. क्यों? Because it is only because of the convergence of trade winds. Now all the factors of these high pressure and low pressure belt, they would shift towards the north. So now, after means when there will be summer, these trade winds will be shifted up to this location, and these trade winds will be shifted upwards to this location. Now the convergence zones will be here only. Yeah, in summer. In winter, again they will shift towards the south. In winter, it will shift towards the south. So this ITCZ shifts towards the north and south as sun shifts towards the north and south of the equator, right? So this is very important, and because of this ITCZ shifting, monsoon occurs in India. We'll study in detail, right? Exit. Yeah, this is your factors of wind direction, Coriolis force, right? I have told that if wind is flowing in this direction, right, this is the net balance or net force of this Coriolis force in this direction and pressure gradient force in this direction. Okay, so because of the balance between these two forces, it is going in this direction, and an opposite frictional force on the opposite direction. Right? Wind in this direction, This is the high pressure, this is low pressure. So pressure gradient force in this direction. Okay, from high to low. A Coriolis force in this direction because of the Earth's rotation from west to east, right? Because Earth is rotating like this, Coriolis force happens to be in this direction. Means you can tilt it like this. In the case of as in the case of means this direction, you can see this is the direction of Westerlies on the southern hemisphere.
Indirection opposite friction like optical so wind like high pressure to low pressure होता है लेकिन high pressure low pressure सेट है like
ये और ये तो आप इसको ऐसे कर लो
तो low pressure नीचे आता है
अरे इसको ऐसे भी बना सकते हैं ना यार कोई दिक्कत नहीं है ना ये हाई प्रेशर यहाँ है इसको यहाँ कर लो ठीक है ये लो प्रेशर को यहाँ कर लो like this is your subtropical high pressure belt this is your 0 degree equator this is your 30 degree north what will happen now this will be the PGF pressure gradient force right now what will happen that there will be a Coriolis force in this direction ठीक है that is why the actual direction of trade wind is the balance of this and this force and an apparent force of friction. This is your trade wind, right? Any confusion?
I took wind direction as a center. The pressure gradient force which may actually that is the main reason.
Yeah, that is the main reason. Yes. Yes. Now you can see here this geostrophic wind, right? What is a geostrophic wind? अभी आते हैं इसमें. Geostrophic wind, your jet streams or geostrophic winds. Jet streams are an example of a type of geostrophic wind. Okay. They are also known as thermal winds because they are caused by thermal gradient. They are caused by thermal gradient. I will detail it. Just note down here. Such type of wind which blows parallel to the isobars is called a geostrophic wind. A wind which blows parallel to the isobars is called a geostrophic wind. What happens here? That there is an isobar. They are shown in millibar, right? Like here it is 1000, here it is 1050, here it is 950. Okay, means here is a high pressure zone surrounded by these isobars, right? Here is a low pressure zone surrounded by these isobars. Isobars, you know, that lines connecting the equal pressure zones. They are called isobars. Means here, 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 here on these points, the pressure is same, 1000 millibar. Here on all these points, the pressure is same, 950 millibars. Right? Here on all these points, the pressure is same, 1050 millibars. Right? But conclusively, this zone is having a high pressure than this zone. Here, this will be like this. Like here, 700 millibars. Here 750 millibars, here 800 millibars, here 850 millibars, right? So this is a low pressure, this is a high pressure. So air will be flowing in this manner. PG of pressure gradient will be from here to here, low to high. So normally the winds flow perpendicular to the isobars, right? Normal winds, they flow perpendicular to isobars because isobars are like this and the wind is flowing perpendicular to the isobars. But on the geostrophic wind case, the winds flow like this. This is an example of geostrophic wind here in this diagram. The wind is flowing in this direction. They are the parallel, they are the isobars, and wind is flowing in the same direction of the isobars, right? So this is an example of geostrophic wind, and here you can see that there is no frictional force. No frictional force. Because this is a wind aloft. This is a wind in the upper air. Yeah, these geostrophic winds, you can find only these geostrophic winds in the upper air. Geostrophic winds, you can find geostrophic winds in the upper air only in the absence of frictional force. Means this is the main reason of geostrophic wind. First, you should understand its definition. That what is a geostrophic wind? A geostrophic wind is a wind which is flowing in the parallel of isobars. So how such parallel movement is caused? Because of the absence of this frictional force. Where such type of absence of frictional force can happen? In the upper air only. Because in the upper air, I have already told that there is, means as you go up, friction of the land will decrease. Okay, so in the upper air there will be no frictional force, and the what happens here, you can see in this diagram only. Like this is the pressure gradient, right? As like this, 950, 945, 940, 935, 930. Okay, these are the, means here the pressure is decreasing. Means as a particle of air is starting its movement from here, means you can imagine it like this. Like this is your 0 degree equator. Okay, this is your 0 degree equator, or you can say 0 degree is not needed. This is your 30 degree. Like this is your 30 degree and this is your 60 degree. Means this is 30 degree north, this is 60 degree north, right? What is happening here in 30 degree north? I think I should detail the jet stream concept directly. Okay. Now, after understanding this concept, your jet stream will be very much easy. Okay. What happens? Jet streams or thermal winds, they are caused by thermal gradient. What is thermal gradient? Up to now, we are studying the pressure gradient only. Okay. The gradient which is caused by temperature changes. Right. So again, I will go to our whiteboard, right?
Introducing the Prelims Target course and Prelims test series at ProdEgyIAS. Designed for UPSC Prelims 2026, this comprehensive program offers in-depth classes on history, geography, science and tech, environment, polity and governance, and economy. Stay updated with current affairs and sharpen your skills with our Prelims test series consisting of 50 full-length tests covering all subjects along with CSAT. Join ProdEgyIAS and stay ahead.